all of you. Today we shall discuss Module 4, Session 7. In this, we shall discuss Aneka MapReduce programming concepts. The Aneka uses Google and Hadoop underlying techniques. So Aneka and MapReduce with Google support. It works on top of Aneka. The MapReduce programming model defines the abstractions and runtime support for developing MapReduce applications on top of Aneka. So Aneka platform will be the underlying platform for executing MapReduce programming. A MapReduce job in Google MapReduce or Hadoop corresponds to the execution of a MapReduce application in Aneka. Because Aneka platform has been developed based on the concept of Google MapReduce or Google File System as well as Hadoop File System HDFS or HDFS. The application instance is specialized with components that identify the map and reduce functions to use. These functions are expressed in terms of mapper and reducer classes that are extended from the Aneka MapReduce APIs. Here in this Aneka MapReduce programming model, there are main elements which will support programming, which are MapReduce scheduling service, MapReduce execution service, and a specialized distributed file system. Mainly MapReduce scheduling service, which plays the role of a master process in the Google as well as Hadoop implementation. MapReduce execution service, which plays the role of the worker process in the Google and Hadoop implementation. A specialized distributed file system that is used to move data file will also be there as the main component for execution. So there will be a runtime support for executing map and reduce functions. As I already told you in the previous session, map and reduce will use large amount of data files which are considered to be data sets, and these data sets are segregated into or split into pieces, and these sub files or sub data will be fed to mapper as well as reducer. So to do this process in a distributed environment, the files need to be sent to various processing elements which are considered to be map reduce execution service models. These split files are executed for mapping as well as reducing should be controlled by a scheduler. The scheduler will schedule jobs to these processing elements. For that, scheduling service model need to be available in the Aneka cloud. Once output of these MapReduce execution service models will be taken back as outputs to the client. Actually, from the client machine, the large data set will be fed to the MapReduce execution service as well as MapReduce scheduling execution service as well as scheduling service. So this will be done by the MapReduce application model. So the MapReduce application model actually will have a reducer as well as a mapper, and this will split files into pieces, and these files will be fed to various MapReduce execution service models. Once these service models execute map and reduce task, the files which are considered to be intermediate files, which will be sent back to the client. Again, before getting that file into client, there will be a MapReduce application. Again, it will merge all the intermediate outputs as a single file, and it will be sent back to client machine. We shall see the total infrastructure of Aneka MapReduce application here. So this picture depicts the entire process. Client machine will have input data files. Multiple input data files are available. These files are sent to MapReduce application, and then these files are, split into pieces. You can see split 0, 1, 2, 3, 4 like that. So any number of splits will be there. These will be sent to the MapReduce task managers, task executors. These are intermediate nodes. This will take care of the execution of files. MapReduce functions will be there in all these processing modules. I have already told you a MapReduce implementation must be there in all the systems where MapReduce functions can be executed. So correspondingly, files will be sent to these processing elements, and once the task is executed and the intermediate files are created. So for the purpose of scheduling jobs, because multiple times the same MapReduce functions need to be executed in these processing elements, so a scheduler service required to assign jobs to these MapReduce execution service models. So once outputs are generated as intermediate files, it will come back to the client machine. So this picture is explaining you the entire process of MapReduce infrastructure in Aneka platform or Aneka cloud. Okay, next we shall see how these map and reduce programs have been implemented. In this case, you should know about some abstraction of object model for MapReduce function. Okay, there are multiple classes defined for MapReduce implementation. As you know already, map and reduce will use a key value pair for getting the mapping function done as well as reducing operation done. So we shall see the next how. Yeah. So in this picture, you can verify. Look at page number 8.72 in the regular textbook also for this picture, which is explaining you the implementation as well as the interfaces as well as classes definition for map and reduce abstraction. Okay, so as you know already, these are abstractions which are defined for the actual implementation. All are implementation interfaces, and these interfaces can be invoked in your actual program. So the first one is IMAP input interface. For example, properties of those have been defined as key as well as value. So for every IMAP input value, you will have a key as well as a value. Similarly, there are key value pair type aware interface. So get key type, get value type. I have already told you large data set will be having heterogeneous data, unstructured data, a different type of data will be coming as a stream of data. Then you need to worry about the type of data as well as the value of the data. So you need to have an interface for verifying the type of the data. Next, IMAP input k comma v, that is k comma v is property as well as a key value. So key property as well as value property for any particular input. Similarly, mapper base, reducer base have been defined. See, when a base class is defined, it's an abstract class which are having methods, emit method, get key type, get value type, map, as well as mapper base. Similarly, reducer base will be having emit, get key type, get value type, reduce and reduce base. As we have taken an example for converting a large data set into segregated words, maybe we will consider one program where a lot of English words are coming and you need to segregate them into various set of words. So when you are looking at set of words, you will be having a type of word. So as we have seen in another example, type of ball is there. There is a red ball. So many red balls are there. So many green balls are there. So many yellow balls are there. So you will be having how many balls are there among them, how many red balls are there, how many yellow balls are there. So there can be, first you need to map all the items into the type of ball, and then you need to count the number of balls available. So that is the reduce function. Similarly, here also you will be doing that job in these programs which we are going to see in the next slides. For writing these programs or developing these programs, you must have these interfaces. Similarly, we have map reduce manager. Look at the fields available here. So scheduler service is defined here as a property, and create job info. For every job which will be sent to the executor, you will have a job info, download output files, handle job finish, unit configuration, initialize storage client, map reduce manager, on handle error. So anyway, you need to do some exception handling. So that exception handling is handled here. So on handle error, because you are executing in a distributed environment, because of error in the program, the distributed system should not be in trouble. So you need to do exception handling mechanisms here. For doing that, all these methods are used, or the functions are used. Online on handle error, query job, shutdown, maybe you need to stop that execution, stop application. So submit application, upload input files, as well as wait finish. So you wait finish is very, very important, because once you are scheduling a job to the map reduce executor, until that job is completed, you should wait. So there must be a process, background process, which will be running for verifying the completeness of the execution of that map reduce function. So you can see in the top model here, we have so many properties defined. Map reduce application properties. This is a generic class. Attempts, fetch results, is input ready. Look at it, a log file. So is input ready, which I have explained you in the form of producer and consumer problem. So there should not be any race around condition for execution. So you need to verify whether input is ready, log file, how many partitions you have, sync reduce, use combiner will be there for the properties. And there are methods: map reduce application, set up map reduce, verify bool property, verify integer property, because the type of data which will be coming for the map as well as reduce function need to be verified, which we have seen in the map input data as well as map key value pair data. Okay, so this is the abstraction of object model defined for MapReduce. Okay, next we have first listing of map function. Here you can just go through the program which has been written in Aneka platform, which will be executed in Aneka platform. Aneka uses Aneka.MapReduce internal. That is the interface which will be used for, it's a library, and also the interface which will be defined for execution. There is a namespace Aneka MapReduce. Okay. Here IMAP input KV is the same property which has been shown as a abstract model, which has been shown here. K is a key value, V is a value, V is a value for that key. So here properties have been defined for execution of get command. Get will be used for getting the value. Similarly, the next is delegate map emit delegate defines the signature of a method that is used to do emit intermediate results generated by the mapper. So every intermediate result will be shown, or it will be sent back to the mapper. That is used by this map emit delegate. So generated by the mapper, which will be sent back to the map reduce function, where it will be reduced and the final result will be generated. Next we have a mapper KV. It's a mapper base, which is a child class for the mapper base, and in this it emits the intermediate result source by using do emit. Next one is a map function. Please note, these are all just in the abstract model. Suppose you want to work on this Aneka model need to be configured in your system, and then you have to start working on it. Similarly, Google, Amazon will also provide similar support for MapReduce functionalities. You can use it. Similarly, Hadoop also will support that facility. Okay, next is a map function, which gets the type of the component of a pair, where key value as well as a key value pair. So you get it a type instance containing the metadata about the type of the key will be taken for the mapping. So how the data comes, it will verify whether that data can be mapped to any one of the mapper sets. So then it will be added to that set, and then it will be reduced at the later stage. Next, we have a summary. The function map is overridden by users to define a map function. So we can also define our own map function to support a mapper for any particular segregation of data. Once you segregate the data, and then you can merge them together using the reduce function. So next is a simple mapper implementation given. The first class is this program written for word counter map. So there are files which will be having so many words in it, and then that will be fed to this mapper as well as reducer function. The file size is very large, and that file will be divided into pieces, and the piece file will be sent to each MapReduce implementer or MapReduce executor model. So this word counter map extends mapper and provides an implementation of the map function for the word counter sample. This mapper emits a key value pair word comma I for each word encountered in the input file. Okay. Word counter mapper, what it does, reads the source and splits into words. For each of the word found, emits the word as a key with a value 1. So key value with 1. Similarly, all key values will be taken into one set, and then it will be added up. So for a particular key, so many words are available in the particular file. Very easy to understand. Suppose how many simple are there in this file. Okay, how many class words are there in this file? If you count it, you start counting class, another class here, another class here. So you will have number of words in it. So once a mapper is taken this as a file, mapper will give class comma 1, again another class comma 1 here, another class comma 1 here. So all these classes will be merged, and then class comma 3 will be there. Suppose you have 3 classes here, class comma 3 will be the reducer job. So that information will be sent back to the client. So like that, irrespective of the size of the data, size of the data set, the number of words and as well as the count will be taken. Maybe one more important thing you need to remember here, because in the intermediate file also class may be there, because when we divide the files into pieces, these pieces will be sent to these executors. These executors will send that file to the reducer for reduction. So these are considered to be intermediate files. So these intermediate files, again it will be sent back to the reducer. So again it will be applied. I have already given you this example similar to divide and conquer technique in algorithms. Okay, another one is a simple reducer implementation k comma v here. Class word counter reducer implementation for the word counter application. This reduce method iterates all over values of the enumerators and sums the values before emitting the sum to the output file. This is what I was mentioning. The reducer takes all the mapper value, mapper data, and then it counts how many words are there, and then that will be the total sum of the value. So key value is class, the sum will be 3 or 10 or 20. So that is a procedure. So you can see here the function input move next, value equal to input current, sum equal to sum plus value. So here you are getting the sum of all the values. So for each word you will be getting the sum. Okay, I'll stop at this point. If you have any queries, you can ask me, and then we will move on to the next presentation.